Yeah, still continue from 1.4. I still have a little material to cover. The spill, let me call it a spillover. Just a very little bit. Yeah, and that's for question like number 44. Question like number 44. There are 5 questions there. Each one of them, I believe, requires some specific attention. Suppose part A, find the real solutions for the equation x to the power of 3/5 equals to -27. Now, how do we solve this? How do we solve this? We can do it this way. We can do it this way for this question, but the following method is a bit too fast, and in some cases, you will see later on, it brings us to some problematic solution. So I take the power, I take the reciprocal of this, bring the equation to the power of the reciprocal. Okay, now the idea is so that these two cancels, right? 3/5 times 5/3 cancel, and we end up with x here. Okay, and then what happened here is to the power of 5/3, we take the cube root of that -27 first and take it to the power of 5. Okay, and that's equals to the cube root of -27 is -3 to the power of 5. That's negative of 3 to the 5th, which is 243. Okay, now I personally prefer to slow down a little bit from here. I prefer to do it this way. I slow down and I see that x to the power of 3/5 as the 5th root of x to the power of 3 equals to -27. Now then, to cancel this power of 3, I do cube root in the next step. So I have the 5th root of x equals to the cube root of -27. Now, 5th root of x equals to -3. Now then, I take it to the power of 5. I will get the same answer. Okay, so we have 2 different ways to do it here, but you will see one of them maybe, it's a bit dangerous. One of them is a bit dangerous. Okay, why? Let's see. For example, part B, we have x to the power of 2/3 equals to 25. Now, you see that if I do it this way, if I take it to the power of x to the power of 2/3 and I take it to the power of the reciprocal of the exponent, okay, now you may not realize that we may have done something wrong later. Okay, well, we cancel this, so we get only x, right? Okay, now then, the square root of 25, take it to the power of 3. So this will be 5 to the power of 3. This is 125. Now you will see something not right here. You will see something not right here later on. So I show you the method that is dangerous in some cases. because if we do it too fast, this is what happened. Okay, now let's see if I do it slowly. Okay, now this is the cube root of x being squared equals to 25. Now you see that I need to do the square root property first, right? Okay, when I apply square root property, notice that I'm supposed to use plus minus. Okay, that's the one missing earlier. That's the one missing here. You won't realize that. You won't realize that because the power of 1/2 means square root, while when we do it slowly in solving this equation, it's supposed to be with plus minus. Okay, so if I go on, then I will get cube root of x equals to plus minus 5. Now then, cube root of x equals to 5 implies x equals to 5 cubed, which is 125, while cube root of x equals to -5 means x is -5 to the power of 3, which is -125. Okay, so you see in this case that the blue method, the slower method, is actually, of course it's slower, that's because we want to be more careful. Okay, that's something you won't be able to see if you kind of rush it, you're using red color. I would like to say that the red color, you will see red color later on will be okay only when the exponent here, the rational exponent, are both odd. The numerator and denominator are both odd. Okay, when any one of them even, you better slow down using the blue color. Okay, now let's see more. Part C, how about x to the power of 4/3 equals to -49. One of them is even, right? On the exponent, in this case, the numerator of that exponent is even. So doing it using the red color may not be a good way. But let's see. If I do it that way, the power of 3/4 equals to -49 to the power of 3/4. Here you will see, oh, the fourth root of -49, oops, fourth root of -49 to the power of 3. This itself already not a real number. This itself already not a real number. Okay, because nothing to the power of 4, nothing to the even power will give you negative number. Okay, nothing, anything to the power of 4 will always be 0 or positive. Okay, can never be negative. Okay, now let's see if we do the slow motion one. The cube root of x to the power of 4 equals to -49. And I apply the fourth root, right? Because it's the even index. When I apply the fourth root, I need to use plus minus, right? Okay. Which, if you think about it, this plus minus have the same issue with part B, which was not out here. Okay, we don't have that there. Okay, we still get the same answer in this case, but that's because it happens to be negative inside the fourth root, right? It happens to be negative inside the fourth root. So we will say no real solution. Okay, so in this case, both methods will give us the same answer, but imagine if this were a positive 49 instead, then we would have a solution here, only one solution, while here we're supposed to have two solutions. Okay, so it happens to be negative that we are fine, but if that both of them get the same solution, right? Okay, but if that were a positive 49, then the red method will get only one solution, the blue method will get both solutions. Part D. Part D, x to the power of 3/2 equals to 64. Using red method, x to the power of 3/2, I take it to the power of 2/3. That's 64 to the power of 2/3. Again, so that the exponent cancels. Then I get x equals to the cube root of 64. Now, cube root, any odd root, if the index is odd, we don't need to use plus minus, right? Okay, but because it comes from 1/3, in any way, we will not do the plus minus. So this will be cube root of 64 is 4 square, x equals to 16. While if we use blue method, the slower version, you see that one of the denominator here, the denominator of the exponent is even. Okay, so we may need to slow down a little bit. Okay, so square root of x taken to the power of 3 equals to 64. Square root of x equals to the cube root of 64. Because it's odd index, we don't need to use plus minus. It's 4, and then we square it. Okay. Now you see that the blue color still gives us the right answer, but the red color has one case in which you don't have the right answer. Part B do not give us the right answer. Okay, let's see the last case. So how do we know, Thomas, which method to use? If I were you, I would use the blue one. Part E. X to the power of 3/4 equals to -8. Red color. X to the power of 3/4 to the power of 4/3 equals to -8 to the power of 4/3. X equals to the cube root of -8 to the power of 4. Is that right? And that is equal to -2 to the power of 4. X equals to +16. Now, let's see the blue color. Let's see the blue color. This is the fourth root of x taken to the power of 3. Now, then I apply cube root to both sides. I get cube root of -8. That's the fourth root of x equals to -2. Now, but if you think about it, notice that this basically gives us the positive branch. The value on the right hand side here, this guy here, by definition means uh, it should give us the positive branch, the principal branch. Okay, principal branch. Of fourth root of anything should be greater equals to 0. So this is supposed to give us no solution. Okay, it's supposed to give us not real solution because square root of anything should be 0 or positive. Fourth root of anything should be 0 or positive. Okay, so again, you will see that the blue color actually is superior. The blue color, the blue method here is superior to the red method. That's because we slow down and we see possible mistakes. Now, under what situation, Thomas, then how to fix the weakness of the red color? To fix it, what you can do is you check. To fix that, what you can do is to check. So whatever answer you have on the right-hand side, the red color here, okay, what you can do is you check. But still, if you do checking, you get this answer, you don't get this answer. You will be missing this answer. This is the answers missing in part B. Okay, it's supposed to have two solutions, but you get only one method using red color. Okay, now using red color here, you get a solution which is supposed to be no solution. Now, if you check this, I want to show you that this 16 is wrong. Okay, so imagine if I have, oops, imagine if I check that I have 16, 16 to the power of 3/4, is it equals to -8? See, 16 to the power of 3/4 means the fourth root of 16 taken to the power of 3, right? But fourth root of 16 should be a positive number. A positive number to power of 3 should be positive number. Okay, so you see the red method here, is actually very unstable. Now, the reason I mentioned this red method here is because I have seen some people actually using that method. And I want to say that it's actually okay for you to use this red method if the numerator, I mean the exponent, both has the numerator denominator odd numbers. Okay, but once any one of them even, I would say that we never know. Okay, I would say we never know. Okay, so I strongly suggest you to use the blue color method in solving an equation with rational exponent. Basically, you reinterpret the exponent, the rational exponent, into the radical with the integer exponent. Okay, yeah, that's for that one. And there's one more question I would like to go, actually two questions. One question that I would like to go over from yesterday is number 38, which is parallel to your number 37. The one I said yesterday, oh, you know what, when you do that, you need to be a bit careful. Not careful, I should say that question is tedious. Number 38, I get 3y to the 4th minus 5y squared plus 1.5 equals to 0. you can kind of imagine this as 3 over 2 if you like. Okay, so if you see it that way, 3y to the fourth minus 5y squared plus 3 over 2, and you don't like fractions, then you multiply the equation by 2 just to clean up the denominator. And you will see this is not factorable. Okay, you will see this is not factorable. So you will proceed using quadratic formula. And so this is a square. That's a quadratic-like equation. Proceed with substitution and quadratic formula. Now you can try to do it that way. Now I will just go ahead with quadratic formula here because you will see that my discriminant is actually still a nice number. So let's blue color here. So my A is 3, my B is -5, my C is 1.5. I usually actually make it work it out using the red color though, but for some reason here, you know what? Let me say let me erase that first. My bad. Let me make a quadratic-like equation first. So let u equals to y squared. So my equation now becomes 3u squared minus 5u plus 1.5 equals 0. And then my A is 3, my B is -5, my C is 1.5. So u, there will be 2, right? u1 and 2 will be -b plus minus square root of the discriminant over 2a. The discriminant is b squared minus 4ac. I'm supposed to do the discriminant first. Minus 12 times 1.5, that's 18. So the discriminant is 7. So u1 and 2, as I proceed, I will get 5 plus minus square root of 7 over 6. Now remember I told you when you have your answer, you need to split it here. One of the main reasons is because you have this situation, 5 plus square root of 7 over 6. And for u2, let me write it here, that's 5 minus square root of 7 over 6. Now notice that 5 is greater than square root of 7. 5 is greater than square root of 7 because 5 is equal to square root of 25, right? Okay, that's a good thing to observe. In other words, this u2 is still a positive number. Okay, why do we need that to be positive number? Because when we put that back to y, I need the expression on the right-hand side to be positive because when I do the square root, it has to be non-negative. And don't forget, I need to put that plus minus. Right, you see it there? Okay, now then I need to rationalize the denominator, right? Then we multiply the top and the bottom by 6. So I get y equals to plus minus square root of 32 plus 6 radical 7 over 36. So that I can bring the over 36 out, becomes 1 over 6 square root of 30 plus 6 radical 7. Okay, now there are two solutions there, but that's for u1. For u2, I get this is u2. Let me don't write it u2, the y2. Let me write it as y squared for now. So 5 minus square root of 7 over 6. Notice that again, I say that the right hand side here is positive, so I can apply the square root property. That's plus minus square root of 5 minus radical 7 over 6. Now, with the same procedure to rationalize the denominator, yeah, otherwise you will get square root of 6, right? Okay, let me just rationalize it right away. So now I get y equals to plus minus square root of 30 minus 6 radical 7 over 36, which will give me plus minus 1/6 square root of 30 minus 6 radical 7. So we actually have 4 solutions. Y1 is the positive of the positive branch. Y2 is the negative of the positive branch. Y3 is the positive of the negative branch. And Y4 is the negative of the negative branch. A lot of solutions, huh? So when you do number 37, you may encounter something very, very similar to this. Now, the thing is this though, when we do math problem, we have a tendency to expect that the answer is supposed to be a nice answer, okay? And every time we see ugly answer, we tend to use calculator. But once you go to calculus though, no, you don't go to calculator right away. Okay, you always get the exact solution first, like this, before you use your calculator. Okay, don't use your calculator too early. Don't use your calculator too early. You may miss important gems, important diamonds, important golds, important treasures, and you cover that with decimal dirts. Okay, something really nice becomes so ugly because you don't see that to the core, the exact value. Okay, and then let me go on further. The one that I promised you yesterday that it's not in our textbook, but it's something very important actually in our pre-calculus. Okay, and I kind of like feel strange why our textbook didn't mention this in our 1.4, while it actually mentioned that in 1.1. Okay, the following issue. Go back to absolute value. Now, please remember that yesterday I said when you have absolute value of something equals to C, where the C is positive, then your next step will be either X equals to C or X equals to negative C. For C equals to 0, then absolute of X equals to 0 basically means the X has to be 0. Okay, now, and oh yeah, you know what, and for the constant to be negative, absolute of X equals to a negative number leads to no solution. Okay, now that's what we have yesterday. Now, the issue is what happens if we have what if we have, what if we have variable in place of constant? Let's say, for example, we will later on attack the following question. Solve absolute of x plus 2 equals to, let's say, 2x minus 1. Let's say we have that kind of question. Okay? Now, but before I answer that question, let's do some foundation first. Now, instead of just simply calling that idea, I call that foundation because this is very critical. Now, we have known that absolute of 3 equals to 3, absolute of -4 is positive 4, right? Absolute of 0 is 0. We know that already. If you don't know this, drop the class. Okay, no, you are in the wrong place if you don't know this. Okay, you're supposed to know this already. Okay, now we know that what absolute value is doing is to give us, quote unquote, the distance of that expression, or in this case, the distance of these numbers from 0. Okay, so the outcome of an absolute value should be either positive or 0. Okay, we know that absolute of anything should be positive or 0. That's a very, very important foundation. So how do we then express absolute of x? Now we say absolute of x equals to x itself as long as that x is positive or 0. Right? Okay, so when inside the absolute sign is positive, the output will stay positive. If inside the absolute sign is 0, the output still itself 0. So if the guy inside the absolute value already positive or 0, then you just basically do it as is, as long as that x is positive or 0. Now what happens if that x is negative? Like in this case here. What if the guy inside the absolute value is negative? Then you make it positive, right? Now, how to make negative number, -4 in this case, becomes positive 4? The way to do that, we apply another negative. We apply another negative as long as the x inside the absolute sign is negative. Okay, so if we look back, how do we get that 4 here? That's because I slapped that -4 with another negative. That's how I make it positive. Okay. Now, as we go on, we will use this idea in more complicated setting. If you think you don't know what to do, then this is actually how you settle to. And that's the technique we do in pre-calculus. When you deal with absolute value and you cannot just handle it with regular way, the way we did up here in the red color. If you cannot handle that with the red color, in other words, the other side of the absolute value is not a constant, therefore we cannot decide what to do, then we will do the following. We'll do the following. So absolute of blah equals to blah for blah positive or 0, negative blah for blah negative. Okay, so how do we bring this issue up? So how do we take care of, for example, absolute of x plus 7, for example? Then we say absolute of x plus 7 is equals to x plus 7 for x plus 7 positive or 0. In other words, for x greater equals to negative 7. And that will be negative of x plus 7 for x plus 7 less than 0. Or when x is less than negative 7. Okay, let's do one more example. Suppose I have absolute of 3x plus 4. Absolute of 3x plus 4. So you see that 3x plus 4 equals to 0 when x is negative 4/3, right? Okay, so absolute of 3x plus 4 will be 3x plus 4 itself when, or for, x is greater equals to negative 4/3. Imagine if you make it greater equals to 0. Greater equals to 0. Okay, and it will be negative of 3x plus 4 in parentheses whenever it is on the other side when x is less than negative 4/3. Okay, so Thomas, what this explanation here has to do with the example you have up here. Okay, then let's go back to this example. How do we solve this problem? Copy that, put it underneath here. Example 1, solve that. Oops, why must we say something? So the way I do it is the following. Now, when solution for x greater equals to negative 2, you wonder where I get that from. I get it from x plus 2 greater equals to 0. Okay, for x greater equals to negative 2, then the right-hand side expression here will be, you just take off the absolute sign without any change. Okay, and then I solve it, that's 3 equals to x. But then make sure, when you say 3 equals to x, you need to make sure that it satisfies the requirement that x has to be greater equals to negative 2. Okay. X equals to 3 satisfy x greater equals to negative 2. So this is a check here. It satisfies the requirement that x greater equals to negative 2. Now, what happened for x less than negative 2? when x is less than -2, then this expression here will be, the guy inside the absolute value will be negative, right? Now to make it positive, I put another negative in there. So negative x minus 2 equals to 2x minus 1. Negative 1 equals to 3x. X equals to negative 1/3. Then you check with the requirement here. Notice that is negative 1/3 less than negative 2. That's not true, right? That's not true. The one here is true because 3 is greater than or equal to negative 2, right? Not here. So then the solution, is x equals to 2. That's how we solve that. Okay, that's how we solve that. Now, do not say just Thomas. So Thomas, can I just do it using left-hand side and ignore the right-hand side? Like you don't do this at all, for example? No, you still need to show it though. You still need to show it. Okay? You still need to show it. And I have asked questions in the past where that I get both of them right. I have questions in the past in which I get both of them wrong. Okay, so you have to do it both ways. Okay, so you have to do it both ways and check. Okay, now let me give you some analysis on geometrical analysis on why we get what that is. Now I have a software here, a graphing software. Okay, now let me graph y equals to 2x minus 1. That's what it looks like. That's what it looks like. Y equals to 2x minus 1. While when I graph y equals to absolute of x plus 2, that's what it looks like. You see? Okay, so the purple equation here gives us the purple curve. The red equation here gives us the red curve. And they intersect only at one point. Okay, but it is possible, however, they don't intersect at all. It is possible they don't intersect at all. Let's say this one here, they don't intersect at all. However you zoom it out, they don't intersect at all. Okay, it is also possible that it actually intersect at two places. Let's say if I use 0.5x plus, let's say plus 2. You see that they actually intersect at two different places, right? Okay, so it is possible that you get two solutions. It is possible you get no solutions. It is possible you get only one solution. It is possible that you only get one solution on the left branch instead. Okay, it is possible you have only one solution on the left branch. So on the left hand side, so let's say I cancel -2 here. Okay, and then I make it 2x, maybe negative 2x plus 1. You see, it intersects on the left branch instead. Okay, so instead of you insisting, but see, Thomas, when I do it that way, then I always get the right hand side method. Well, let me tell you this: if your method, your simpler method, works all the time, I would have taught you that simpler method. The problem is, no, we are in pre-calculus right now. Okay, and we are not dealing with easy questions only. No, we are not. Okay, so the reason I go over this question is because You should expect to see this kind of question in my test, or maybe in my quiz, in my test, in my final, because you definitely see this kind of situation in your calculus 1 later on. Okay, and like what I said on the first day of class, my job, what I want to do in this class is to prepare you for your calculus, right? So we anticipate the basic situations that your calculus teacher expected you to already know when you come to calculus class. Okay, now that's the spillover from our 1.4. I'm kind of a bit surprised that it takes me 50 minutes, 45 minutes for that. Let me go on to 1.6. Like what I said yesterday, I skip 1.5. I go to 1.6. And that is solving inequalities. Change this here. I make it 1.6. And 1.6, we will do inequalities. Now, in this section here, I will first go over, so this is the intro. I need to go over interval notation. And then from there, we will go into solving linear equation. Including later on a compounded linear equation. I think you saw this type of linear equations in your intermediate algebra at the basic level. After that, we will solve polynomial, I'm sorry, not equation, my bad. Erase this, not equation, inequalities. Okay. And then the second part, we will solve polynomial inequalities. And then finally, we will solve rational inequalities. Okay. If I have a chance, I think I want to go over solving. I should go over this solving absolute value inequality. That's an easy one, the easy part, and then the hard part. Okay. I may even do that first before I go to the solving polynomial inequality. Right now it's 12:03. Let's take a break. We come back at 12:10. Let's start. First one, introduction about interval notation. Now, how do we express the solutions or the interval between, this is what we learned from our basic algebra. Suppose I start from 3, including 3, up to, let's say, 7, not including 7. Now, in high school, maybe you use open circle, closed circle, right? Closed circle means you include the endpoints. Open circle, you not including the endpoints. Okay, now, because then you need to go to calculus, then we will need to transition you now to calculus notation. If you include the endpoints, we will use bracket. And if you don't include the endpoints, you use parentheses. Okay, now the good thing about this notation is you actually don't need to shade the middle because it implicitly means so. You see the parentheses on the left-hand side opens to the right, means you go to the right, and I'm sorry, the bracket on the left-hand side opens to the right, and then the parentheses on the right opens to the left. So we know that it actually means this interval. Okay, so bracket means including endpoints. Parentheses not including, not include endpoint. Now, because of this notation, then we know an interval notation for this interval will be written as bracket 3, 7, close parentheses. Okay, that's how we express that. And you will see the number on the left-hand side of this interval notation should be smaller than the number on the right-hand side of this interval notation. Okay. So let's see another example. Let's see another example. Suppose I want to express the interval from, let's say, from -2, including -2, all the way to infinity. All the way to infinity. Now, then, for our pre-calculus level notation for this, on the number line, we will use bracket from -2, and if you want to shade it, you shade it to the right, or you can just highlight using what I did up there. But the interval notation will be what? The interval notation will be from -2 bracket up to infinity. Now the thing is, anything involving infinity or -infinity, you never use bracket. You use parentheses for infinity side. Okay, so suppose you see this notation here. Suppose you see -infinity up to -3 bracket. Now, what does it mean? It means all the numbers from -infinity up to -3, including -3, okay, that's what it means. That's what it means. So bracket, if you include the endpoints, parentheses, if you don't include the endpoints, and anything with infinity or -infinity means you use parentheses, okay? And the expression for all real numbers, let me partition this first. Yeah. If you have the solution is all real numbers, that's the, if we have all real number solution, right? If the solution is all real numbers, then the interval notation will be -infinity up to +infinity, because both of them infinity, then both of them using parentheses. Okay, now in my class, I will use, I can use -infinity to infinity for all real numbers, But I think more often than not, I use this notation for all real number. So it's it's capital R with double line here. That's all real number. The set of all real numbers. And this is actually a notation that you see even in your calculus though. So I start teaching you this notation. Okay, if you see capital C with double line here, that's the set of integers. Now, if you see a capital C with negative here, that's the set of negative integer. If that were a plus sign, then it will be positive integer. Negative integers. Now, if you have capital N with double line, that's the set of natural number. Okay, and if you see capital Q, that's from the word quotient, that's the set of rational numbers. If you go even further, you will see capital C with double line. That's the set of complex numbers. But we don't talk about that here. We don't talk about that in calculus though. Okay. Well, anyway, my main purpose is actually to show you for all real numbers, we can write it with capital R double line, or the interval negative infinity to infinity. Now, one little note. I'm aware some of you come from another country, just like me when I first come to America. My notation may be different from the notation used by Americans. And of course, I will actually, I try not to penalize you if you don't use the notation we use in here, okay? I try not to penalize, but toward the end of this semester, I hope you already transition to the notation we use in America, okay? One thing, for example, in Indonesia, just let you know, in Indonesia, where I came from, when we write 1,000, we actually write it as 1.000. That's in Indonesia. In US, 1,000 is 1,000. Okay? You see a very big difference, huh? Okay, so when I go back to Indonesia and I do my, let's say I did my blood test, okay, their comma is American, Indonesian's comma is American dot, American decimal point is Indonesian's partition, okay? So let's say in US we have 1.7. Just for example, in US, we write that 1.7. This 1.7 is between 1 and 2, right? 1.7. Okay, in Indonesia, 1.7 that we do here in Indonesia, we will write that as 1,7. I think from your names, I know some of you from Mongolia, very likely. Okay, and Mongolia actually follows the same pattern. And I also some Middle East, or if not all Middle East countries, also have this kind of pattern. Okay. By the way, Indonesia is being influenced by basically from Western country, including America, and also from Middle East, mostly Muslims there, right? Okay, I mean, I have no issue with Muslims though. Okay, most of my best friends are actually Muslims, so please don't take it that way. Don't take it as if I say bad things about them. Okay, they're my best friends. No, I'm saying that because of that kind of difference in writing, okay, I hope you can adjust to American, US way of writing, okay? Because it's one thing that I know what you try to write. It's another thing that when I grade you, I have to grade you based on what I see, okay? I need to grade you based on what I see. So please adjust that as soon as possible, okay? Now, another thing is, I also know that in some countries, as I know Mongolia, when they write in coordinate, they use these numbers, let's say 3,4 in America, also in Indonesia. Let's say the coordinate is 3,2, but in Mongolia, it will be written as 3:2. Okay. I'm not trying to single out Mongolia, no, that's what I remember. But I also know that some Middle East country also use that notation, okay? If I see that, of course, I will be okay, right? If you happen to use 3:2 instead of 3,2, I will be okay. But I will put a mark there, okay, to ask you, basically, I will ask you to try to adjust to American way of writing, okay? Yeah. I have no issue with that notation at all. What I mean, let me tell you that I have that notation too when I first came to United States. Okay. Now the thing is though, when I grade you, I have to grade you the same way I grade other people, right? Other students. And in case that my class being audited, let's say a student complained, Thomas, you penalize me too much, blah, 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 blah. Then the person who audit my class may require me to open all the files, all the assignment, all the quiz, all the tests that you gave me. And the auditor may say that, why don't you ding this person some points because the notation he or she uses is not the notation we're supposed to use. Okay, now at that time that I will have harder time to defend you. Okay, so I will do my part, okay, but you help me to do your part also. Okay, yeah, that's about the notation. Now, when it comes to an interval notation, there is a chance also, when it comes to interval notation, there is a chance also when you write this interval notation, you write it as bracket 3:7. I will understand this notation. That's not a big deal. What else can that mean, right? But I would like you to adjust to what it's supposed to be. Okay. Last thing. Let me erase that. Yeah. Last thing. If you come from some Soviet Union country, Russia, for example, you may write your parentheses, let's say 3,2. You may write it this way, like not including, like that. No, I will not accept that though. Okay, I will not. For that one, I happen not to accept that because in some situation it becomes quite confusing. Okay, okay. So I don't mind with colon and comma, even though I ask you to adjust. Okay, but don't use this notation. You don't use this notation. Now, the reason is this notation is not even widely used anymore in the countries which used that in the past. Okay, now I don't really see this case recently. I mean, I think I say like in the last 10 years, I saw only one person, that's one, at most two people use that notation. Okay, so I think it's not something widespread. I hope if anybody using this kind of notation, you can adjust as soon as possible. Okay. Let me say that if I see this, I may put a question mark, but I need you to change right away. So I may ding a little point, let's say half point, just to make you aware that don't give me hard time. Okay. I understand what you mean, but I still have to grade you based on what you write, not based on what I think you want to write. Okay? Yeah. Say what you mean what you say, and make sure you say it the way that other people will understand it. Okay? The common knowledge. You cannot say the following. You cannot say the following. This is the case I have in my stats class. In my stats class, I told them that capital N represent population size. This is statistic in statistics. This is population size. The number of people in the population. Lowercase n is for sample size. Both of them refers to sizes, but one of them population, one of them sample. Now then, what if somebody write this? Thomas, that's how I write my capital N. Well, okay, if you want to insist that's how you write your capital N, then I will say this is how I write my A. You see what I mean? Okay, if you insist your way, my way, your way, then they will never end, right? So instead of saying your way, my way, okay, we follow the one that is widely acceptable, okay? This is capital N. This is capital N. This is still capital N. However small you write it, the way you write it shows that it's capital N, okay? This is lowercase n. This is still lowercase n. You just write it big, call it big baby. Okay, but that's still lowercase n. Okay, no argument about that though. Okay, now, so in my stats class, I told them about this. The way you write it tells me what it is. But Thomas, both of them ends. Yeah, both of them sizes, but one of them population size, which should be written using capital N. However small you write it, the way you write it tells me it is population size. Not about the size, it's about the way you write it. Okay, and this is sample size. That's just a little example about notation in math. There, not that I kind of like enforce it on you without consideration. No, that's part of the training. Okay, think of that as part of the training, so that when you read your textbook later on, okay, you know what they meant. Because when they write textbook, they need to write what they mean what they write. Okay, we cannot say, but you know what I mean, right? If you are not clear with what you tell me, okay, don't expect me to understand you clearly. Okay, don't forget, I have one wife. That's one too many. I love my wife so much. Okay, but sometimes we have issue with our communication because I didn't say things clear enough to her, or she didn't say things clear enough to me. She assumed that I should have known what she said, or I assumed too much that she should have known what I said. But I didn't say that clearly. Of course, she won't understand it clearly too. Okay, yeah. So I hope you understand me in that case about the notation. Now that's for interval notation. Now let's go on to the first topic, solving linear equation. Solving linear equation. Now, why I keep on saying equation? Solving linear inequality. Now, solving linear inequalities is very similar to solving linear equation. Very similar. So not exactly the same, but very similar to solving linear equation. The only difference is when we multiply or divide the equation, I think I should say the inequality, not equation, the inequality by a negative number, then we need to reverse the inequality sign at the same time. At the same time. Okay, now little example. Suppose, for example, if I have negative 3x is greater than 12. Okay, then remember I told you yesterday that when you divide both sides by a number, the next step should be done in the next line. Okay, so you should not do it this way. You should not say, oh, divide by negative 3, divide by negative 3. No, this is a so wrong way to write it. Okay, if I see this, I cross it out right away. No, this is not the way you do it. No, the next step should be done in the next line. And notice that when I divide by negative 3, the left-hand side becomes x, the right-hand side becomes 12 over negative 3, right? But because I divide by a negative number, because I divide by negative 3, then at the same time, I need to reverse the inequality sign. At the same time. At the same time. It's not two steps. It's not two steps. Okay, I know you want to say that, Thomas, you see, if I write it this way, don't you think I get the same answer? Well, getting the same answer doesn't make you right. Getting the same answer doesn't make you right. No, it's something to do with your procedure too. See, you actually violate two things here in this one step. The first problem is dividing by negative 3 should be done in the next step, not on the same step. Okay, so that's your first violation. Second, when you divide by negative 3, you're supposed to reverse the inequality sign at the same time. Okay, so if you divide by negative 3, here, you're supposed to reverse this right away at the same time. No, it's not two different steps. Okay, like when I do, I have red belt in Taekwondo. Okay, like when I do Taekwondo, I don't kick and then punch you. No, it's actually kick and punch at the same time. Okay, that's the illustration. Okay, you do two things at once. Okay, it's like when you try to turn on your car, for example. Okay, if you don't like my illustration in Taekwondo, like when you drive, you turn on your car. Okay, you need to turn it on at the same time you step on the brake. You cannot say, I step on the brake first, and then I release it, and then I turn on my car. No, you have to do both at the same time. You have to step it, hold it there, and then you turn on your car. Okay? Those are not two different steps. Those are the same step. Okay? So the way you show your work should be like this. But the biggest warning is that when you multiply or divide by the inequality by a negative number, either you multiply or divide by a negative number, okay? Then you need to reverse the inequality sign at the same time. That's actually the only difference in solving inequality, linear inequality. Now, let's do example from the book. I pick question number 8. Number 8. X minus 6 greater than 5x plus 3. Okay, write the solution in Inter Connotations. In this class, when you solve an inequality, maybe I write it as when in my class, by default, the solution of an inequality should be expressed in interval notation. What I showed you up there earlier. Unless I tell you otherwise. Okay, unless I tell you, okay, graph it. Then you give me the interval notation first, then you graph it. Okay, now let's see how to solve this. Then I subtract by 3 both sides, and I subtract by x both sides. I get -9 is greater than 4x. Now then I will divide by 4, but 4 is a positive number, right? I divide by 4. Okay? You don't need to show that red marking though. So I get -9/4 greater than x, which means x is less than -9/4, not including the endpoints. Okay. Now, if you wonder why we get that kind of solution, try to graph it first. You get -9/4, right? And not including the endpoints. And x is less than. X is less than. Okay, that's how we get this solution here. Now you may solve that number 8. Let me do just the same problem, but anticipate the situation if you solve it different ways, which is okay. Acceptable different ways. Some of you always like to have your x on the left-hand side. Fine, do it. So x minus 5x is greater than 3 plus 6. -4x is greater than 9, right? But remember, you will divide by -4, right? When you divide by -4, reverse the inequality sign at the same time. Okay, now you see that this is what we get also. Okay, now here you need to reverse the inequality sign because your procedure make the x has negative coefficient, such that for me to get rid of that negative coefficient, I need to divide by a -4 in that case. Now, how about compounded situation, compounded linear equation, compounded linear inequality? I keep on saying equation. Let's say, for example, the easy ones is the case when you have your x in the middle, -2 less than 4x plus 1/3 less than equals to 0. This is question number 10 in our textbook, 1.6. You have x only in the middle term, right? We call it compounded because it actually consists of two inequalities. Okay, if x is located only in the middle term, then we can just solve it all at once. So let's say my red color here is something you don't need to show. Okay, but I show you this so that you know what I do in between. First, I multiply by 3 both sides because it's positive number multiplied by +3, right? So I don't need to reverse the inequality sign. Okay, and then I subtract by 1, I get -7 less than 4x less than, I subtract by 1, this becomes less than equals to 1. And then divide by +4, still safe, I don't need to reverse the inequality sign. Okay, and then so we get the solution will be -7/4, -1/4 bracket. Okay, I think that one is easy. Oh, by the way, some small warning. I know some people try to cheat me, but now I've been teaching uh, I've been teaching for too long. Some people at times they were not sure, should I use parentheses or should I use bracket? So they kind of confused, should they use parentheses or they should use bracket? So they try to be sneaky and try to get it both ways. So they make because they cannot decide, right? Okay, so they make it like this. You see, if you write it that way, you can argue that Thomas, it can actually goes both ways, right? Okay, if the answer is supposed to be parentheses, yes, it looks like parentheses. If the answer is supposed to be bracket, you say, oh, it looks like bracket, right? So Thomas, you cannot mark me wrong for that. No, but if I see this, I will say that this is not bracket, this is not parentheses. Either way, you're wrong. Okay, no. Your parentheses is round, your bracket is short. You have a 90, quote unquote, almost 90-degree angle, should be 90-degree angle there. Okay, so you cannot say, Thomas, my bracket is a bit round. No. If you say, Thomas, this is how I write it, then I will say, this is how I mark it right. You don't like how I write it, then don't tell me how you want to write it. Okay? Okay, I mean, we follow common notation. Okay, things that we agree all on. Okay? Yeah. That's just for sneaky people. I had that before and I was just like, duh. No, I don't expect you do that, but I have seen a couple of times some students actually try to do that to me. Now, but the case that I have shown you I just show you just now is actually the easy case because you have only x in the middle. Now, the following example, I got it from nowhere, is the situation where you cannot do it the way I showed you earlier. Let's say x minus 6 is less than 3x plus 2 and less than 2x plus 5. You can use equal sign somewhere. Let me put it there. Now, the problem with this is however you play with these inequalities, these compounded linear inequalities, however you play that, you cannot have your x by itself in the middle. You cannot have x by itself in the middle. Okay. Let's don't write this down. Okay, suppose you subtract by 2x, right? So this becomes x plus 2. Okay, subtract by 2x, it becomes 5. But when you subtract by 2x, this becomes negative x, right? Okay, you cannot have only x at the end in the middle. However you play with this, however you massage this, you will always have at least two sides that have x in there. So instead of attacking these inequalities, these compounded linear inequalities at once, I will attack that with two steps. So the first inequality and the second inequality. Okay. Basically, I'm saying that this compounded inequalities actually means x minus 6 less than equals to 3x plus 2, and at the same time, and 3x plus 2 less than 2x plus 5. That's what it means. Okay, that's what it means. Now then, you solve each one of them as usual. Negative 6 minus 2 less than equals to 2x. So negative 8 less than equals to 2x divided by 2, which is a positive number. So x is greater equals to negative 4. And at the same time, subtract by 2x less than 5 minus 2, so x is less than 3. Now then, let's put them together. The red ones means x is greater or equals to -4. -4 greater than that. The blue ones means x is less than 3. Now, because it is an n, it means it has to satisfy both. Okay, it has to satisfy both. So the solution will be, -4 up, including -4 up to 3. Now, in set builder notation, you're supposed to know this already also. Okay, that's the set of all x where x is greater or equals to -4 but less than 3. Okay, that's for compound linear inequalities, and you cannot isolate x by itself in the middle. So you kind of break them up into two simpler inequalities and solve both of them. Whatever the answer for each one of them, you do the what we call intersection, the common solution. You need to find the x that satisfy this guy and also satisfy this guy at the same time. Okay. So implicitly, besides teaching you how to solve compound linear inequalities, I also teach you how we actually get the common solution of two inequalities. Implicitly, I teach you that here also. Okay. That's for compound linear inequality. You may see that, you may see this situation again. Oh, by the way, yeah, you will see this situation again in calculus though. At the very beginning, let's say section 1.1, 1.2, 1.3 at your calculus class later on. Okay, when your calculus teacher give you some review, not teaching you something new. And when they give you, when he or she give you a review, your instructor usually go over this kind of situation again, because compounded linear inequality is something we do actually quite often in calculus. I think for the first 3 chapters. Okay. Now, then that's for compound linear inequalities. Let me do polynomial inequalities. Yeah, instead of doing number 4, let me do polynomial linear inequalities first. Did I say polynomial linear inequality? Duh. Polynomial inequality. I can say anytime we solve polynomial or rational inequality, we need to show, and I'm quite strict on this, that's why I write it down, this 3-step procedure. Doing it procedure. Now, doing it other way will get you wrong solutions. Doing it other way will be marked off because there's no other way, actually. Anybody who show you other way will get it wrong. Okay? Yeah, of course, in some cases you get special treatment, okay? But for you in this class, I want you to do it this way. Okay, what are these three procedures? First one, and you need to mark that step one, okay? Step one, critical numbers. Step two, sign graph. And then step three, solution. Okay, I need you to show that work. And I need you to show me that 1, 2, 3 also. Okay, I will do one examples and then I will show you the reasoning why we need these three steps. Okay, suppose for example, we need to solve 2x squared minus 3x minus 2 greater than 0. Then the way you show your work solution, okay. Critical number, step one, and write that number one, and then write that critical numbers. I want you to write this down, at least for now. Okay, critical numbers. Okay, critical numbers are the numbers, the x in this case, where the sign may change from positive becomes negative or negative becomes positive. So what I do when I deal with the critical numbers, I change this inequality sign, make it equal sign first. Okay? When I deal with critical numbers, I change it into equal sign first. Now then, I solve this quadratic equation, of course by factoring, which I assume you have studied yesterday. It is factorable. Negative 2 here plus 1 here. So I get my critical numbers are negative 1/2 and 2. Those are the critical numbers. Now then, step 2, the sign graph. Now this procedure here, I break it up into 3 steps because it will be very useful in a lot of cases, including very useful when you are in calculus class. If you saw my website where you can get my old tests, you also see that I have taught regularly calculus classes. In fact, to be honest with you, I only taught in my lifetime, more than around 24 years teaching, I only taught calculus 1 time at Cal State LA. But I taught a lot of calculus 2 and calculus 3. And I always get pissed off when I have students who don't know how to solve this kind of inequality. They just don't want to stick to the method, to the procedure, and they get wrong solutions without knowing they get it wrong. That's the worst case. That's the worst case, the case that you get the solution, you think it's right, but it's wrong, but you don't even know that it's wrong. Okay, you have so much confidence that you get it right, but no, it's wrong. Okay, now follow this though. Okay, follow this. Now, sign graph. You draw the number line, okay, and you place the critical numbers. Negative 1/2 is of course to the left of 2. Okay, don't use method in our textbook. The method in our textbook basically follows this 3 steps procedure, but when they do the sign graph, they do it way too long. It takes you too much time. Okay, you can take a look in how our textbook's doing that. Okay, but I will not do it that way. I will not do it that way. They take longer time, but they get less information, even though they take longer time, longer steps. Okay, don't use method in our textbook because Again, our textbook basically do this 3 steps procedure, but when they do the sign graph, they do it in a long way because it takes too long. And of course, it implies too much time. Okay. I expect my students in this class later on can answer this question in less than, like, say, 3 minutes. Actually, 3 minutes will be way too long. Okay. 2 minutes will be quite reasonable. And the more complicated the problems we have, the more time we need, right? But the problem is using other methods, including the way our textbook does the sign graph, will actually takes it many times longer. So let's say in more complicated setting, it takes me 5 minutes instead of 3 minutes. Then in more complicated setting using this method, instead of 5 minutes, it becomes 15 minutes. I'm saying it's just like it grows even faster than if you do it with the way I show you. Okay, now I don't blame the textbook for showing it that way because our textbook tried to explain it in details. Okay, but there are details that you can just think of that visually. Okay, now going back to this situation, on this sign graph, this -1/2 will give us 0. Okay, when you plug in -1/2 here, when you plug in -1/2 here or here, of course, the outcome will be 0. Right? Because what? When you plug in -1/2 here, it becomes 0. You see that? Okay. Likewise, when you plug in 2 into that into this expression here, when you plug in 2 in this expression here, you will see this will make it 0. Okay. So above that 2 on the number line, you write 0. This is basically refers to the y value of the expression the y value of that expression for this expression, which is this expression, which is this expression. Okay, the y value of this expression from the x value here. So when x is -1/2, that expression is 0. When x value is 2, that expression is 0. Okay, when x is -1/2, this is equals to 0. When x equals to 2, this is also equals to 0. Now, where's the sign graph start to come in? You need to start with this first. Okay, you need to start with this. Okay, now we say that this -1/2 and 0 are critical numbers because if there is any change of positive negative sign, positive or negative here, positive negative here, positive or negative here, okay, if there's any change of plus becomes minus, minus becomes plus, it must happen at those points. That's why we call that critical numbers. Okay, that's why we call them critical numbers. Let me show you the graph of that inequalities. The graph of that expression. Let's see, where's that? What? Why can I close that? Give me a second. I want to show you this guy here. Two x squared minus 3x minus 2. That's what it looks like. That's what it looks like. Okay, now when we say it's positive or negative, give me a second. I want to click that. This is the side news. Now, you see that negative 1/2 is located here. That's negative 1/2. And this is the 2. Right? Now then, when we say we want to have greater than 0, it refers to what are those axes such that the value of the expression is positive. Okay? It refers to this hands here, refers to this. For this axis, for axis between negative infinity to negative 1/2, the value of the y is positive. When x is greater or equals to 2, the value of the y also positive. That's what we want. Okay? So how do we know that that's the interval we want? First, we find the critical numbers. Okay, the critical numbers, in this case, negative 1/2 and 2. Okay, and you will see that it breaks the interval, in this case, into 3 parts. It breaks the interval into 3 parts. This guy here, this guy here, this guy here. Okay, now we call them critical numbers, this negative 1/2 and 2, because if there's any change of sign, you will see later on the sign here will be positive, negative here, and positive here. Okay, you will see later on. I will show you later on how to get that plus, minus, plus. Okay, I basically try to say that these are the critical numbers, right? It means the sign, the positive negative sign at negative 2, if that's positive, it will be the same to the sign if you try negative 1. It will be positive also. Why? Because there's no critical number in between. Okay? If you check x equals to 0, right? What's the value for x equals to 0? In this case, it's negative 2. It will be the same sign, both of them negative, with x equals to 1 when you plug in x equals to 1 into that expression. When you plug in x equals to 1, you'll get negative also. The same sign with when you plug in 0. So that's negative, right? I'm not saying it's both negative 3. No, I'm saying it's the same sign, both negatives. When you plug in 0, you will also get negative. Okay? Why do they have the same sign? Well, because there's no critical number in between. Okay? So why we need critical numbers? We need critical numbers because the sign between these two critical numbers, I mean, not between these two critical numbers, the sign to the left and to the right of a critical number may be different. Okay? But for example, if you choose 0 and 1, no critical number in between, right? No critical number in between. So there won't be any change of sign between the value at 0 and the value at 1. Both of them will be negative. Yeah, of course, they have different value, but the sign both negative. Okay? Now, but Thomas, why do we want the plus minus? Because at the end, what we need is, oops. At the end, in this question, what we need is, in this case, is greater than 0, which means we need positive. then that's why we just need the plus minus sign, because greater than 0 means it's positive in this case. Okay, now then going back to that question, how do we know, Thomas, the sign is positive or negative? Now what you can do, you take test point in each interval. Test, let's say the x equals to 0 in this interval. Okay, now you factor it already, right? So you have 2x plus 1, x minus 2. Now replace the x by 0. If you replace that by 0, replace this by 0, then you will get positive 1 here, or positive, and negative 2 here, or negative. The product of positive times negative is negative. That's how I get that to be negative here. So let's try again. What if I want to test the sign in this interval? Then pick any point, any numbers greater than 2 to the right of that 2 in that interval. Let's say you test x equals to 5. Okay, you can use 10 if you want. You can use 100 if you want. Now plug that 5 into that expression. And you don't need to compute precisely the value. You just need the positive or negative. Okay, now here that will be positive 11. I just need the positive. Here, that's positive 3. I just need a positive. Positive times positive is positive. So it should be test, not text. Now, same thing here. You test a number to the left of negative 1/2. A number in that interval, x equals to, let's say, negative 1. Why not? You can use negative 10 if you like. So 2 times negative 1 plus 1 times negative 1 minus 2. This guy here is negative 2 plus 1, that's negative. Negative 1 minus 2 is negative 3, that's negative. The product of two negative is positive. Now then, when we transition to step 3, the solution, now take a look on the expression. The expression we had was 2x squared minus 3x minus 2 greater than 0. And we already did the sign graph for this earlier, right? We already did the sign graph for this earlier. And this guy has to be positive. Has to be positive because it's greater than 0. Boom. Okay, so you look at your sign graph, get the interval that gives you positive y value, and the solution will be negative infinity up to negative 1/2, not including 1/2 because we don't have equal sign. We don't include equal 0, right? It's strictly positive. Okay, and then you continue from 2. That's a union notation here. Union notation. We use that notation to connect two separated interval, like up here, 2 to infinity. Okay, I will do one more example quite fast, and then I will give you a break with some extra examples. And then I would like you to, and then we go on to rational inequality. Okay, so how do you want me, well, my explanation in this example 1, that's a lot, right? Okay, but the work is actually a lot shorter than that. Okay, the work is actually a lot shorter than that. Example 2. Let me go over that example 1 again. Suppose, how do you want us to show the work? How to show the work? because the explanation above includes the idea behind that procedure. Right? So 2x squared minus 3x minus 2 greater than 0. The solution. Step 1, critical numbers. You can just write it this way. Okay, so you said 2x squared minus 3x minus 2 equals 0. Factor and solve. X equals to negative 1/2, x equals to 2. Step 2, sign graph. The number line, put the critical numbers, negative 1/2 and 2. Both of those critical numbers are the zeros. They give us zeros when we plug that x in. Okay, and then you do testing point. Then you say let x equals to 0 here. Okay. Now 0 is between negative 1/2 and 2, right? Now then you plug in that x equals 0 into this factorized form. So 2 times 0 plus 1, 0 minus 2. This is positive, this is negative, so that's negative. That's negative. Boom. Now how about here? When x equals to, let's say, 10. 2 times 10 plus 1 times 10 minus 2. This is positive here. This factor is also positive, so the product is positive. Boom. So on here, when x is, let's say, negative 10. 2 times negative 10 plus 1 times negative 10 minus 2. This is negative 19, that's negative, times negative 12, that's also negative. The product is positive. Boom. Now then, step 3, solution. I need a positive branch greater than 0. Okay, so I need the parts that it give me positive in that interval. So that would be negative infinity up to negative 1/2 union to infinity. That's really fast, huh? You may say, oh, Thomas, you're too fast. Well, because I explained this problem earlier. Now, let's see what happens if we have this thing. Example 2, solve, let's say, x squared plus 4x greater equals to negative 3. Now, remember we want to do sign graph, right? We want to do sign graph such that the other side has to be 0 for us to decide if this side is positive or negative. So let me modify this first, becomes x squared plus 4x plus 3 greater equals to 0. Okay, so this guy, one side has to be 0. One side of the inequality needs to be 0 before you start the procedure. Okay, again, because we do sign graph where we only see the plus minus. Now then, from there, I start the first step, critical numbers. Set that inequality becomes equals to 0, and then factor. And we don't have too much time to do factoring. We don't have that leisure, so you really need to speed up. So we get x equals to negative 3, x equals to negative 1. Step 2, sign graph. get the number line with critical numbers, -3, -1. And make sure you put that -3 on the left-hand side of -1. I mean, you don't put this way. You don't say, oh, this is my -1, this is my -3. No, that's so absurd, right? On the number line, you don't have such a number line ever, okay? Ever. No, -3 on the number line are always to the left-hand side of -1, okay? And we know from our procedure above, the critical numbers give us 0. Boom. Now let's do testing point right now. Let's say test in this interval here, pick a number greater than -1. Let's say I pick x equals to 0. So 0 plus 3 times 0 plus 1. How do you get that times? From here. Okay, now 0 plus 3 is positive 3, but I just care about positive. Positive, the product of two positive is positive. Between -1 and -3, pick a testing point. Let's say I pick x equals to -2. So -2 plus 3 times -2 plus 1. -2 plus 3 is positive. -2 plus 1 is negative. The product of positive and negative is negative. And finally, do a testing point here. X equals to negative what? -5. So -5 plus 3 times -5 plus 1. This is negative. -2 times -4. The product of two negative is positive. Again, you don't need to get the exact value positive 8. No, no, no. You just need the sign. Is it positive or negative? Okay. Now then, once we get that, so the solution, we need the one positive or 0, right? Greater or equals to 0. Okay, greater or equals to 0. So I need the solution will be -infinity up to -3 bracket because I include the 0. Right? Because I include the 0. And then from -1 to infinity, including -1, but never include infinity. Okay. Now let me ask you to try question number. Let me ask you to try question number 32. Solve 8x minus 15 greater than x squared. Yeah, let me give you a hint. Move everything, set one side equals to 0 first. So let me move, I get x squared minus 8x minus 15 less than 0. Okay, try to solve this. This should take you 5 minutes plus another 5 minutes break. We come back at... Okay, let me continue. I make a mistake earlier here. I wrote it as a minus. It's supposed to be plus. And thank you for Kristen correcting me. Yeah, it should be plus there. Then let's see how we approach this solution. Step 1, critical numbers. I set it equals to 0. So x equals to 5, x equals to 3. And then second step, let me do it on the right hand side here. Sine graph. And 3 to the left of 5, both of them the zeros. Now I do testing point. When x equals to 0, I get -5 times -3. It's product of two negative, which is positive. When I pick x between 3 and 5, let's say x equals to 4. Of course, you do not want to choose 4.2 or 4.3. Pick nice numbers, right? Okay, since you have the freedom to pick any numbers, then don't make your life so complicated. Pick nice number. Okay, all you need is the sign. Is it positive or negative? Okay, so this is -1 times +1. Negative times positive is negative. And finally, let me pick x equals to 10 here. You can choose 6 if you like. You will get the same sign anyway. So that's +5 times +7. The product is positive. In part 3, the solution. You need this expression to be less than 0. In other words, we need negative. Right? We need negative. Let me write it there. We need negative. Okay, and then from the graph there, you see, it will be negative when it is between 3 and 5. And we don't have equal sign, right? Okay, so it will be between 3 to 5. Okay, now that's the foundation. That's the foundation. From here, I will do 2 or 3 problems. Okay, from here, I will do, let's say, 3 problems. Instead of dealing with just quadratic inequalities, let's go on to higher degree. Let's say question number 28. The nice thing here is they already factor for us. If not, then you need to factor yourself. Less than equals to 0. So they factor for us, and the other side already 0. If the other side is not 0, if this side is not 0, so even if you already factor the left-hand side in this case, you have to FOIL that first and then change that non-zero become 0 on that side, and then you factor it back. Okay, in other words, you have to have one side equals to 0 first, and then you factor the other side. Okay, so we rely on factoring and 0. Now here they already factor it for us and already set one side for 0. So we can go to solution right away. Step 1, critical numbers. We need that x plus 2, x minus 1, 4 minus x to be 0. So the critical numbers are x equals to -2, x equals to 1, x equals to 4. And then step 2, the sign graph. I think tomorrow I can give you a bit more shortcuts such that instead of doing a lot of testing points, you can just do one testing point and get the sign for all intervals, all these intervals. Okay, yeah. Some of you may observe that the sign always alternate. Plus, minus, plus. The sign always alternates. So far, that's the case. Okay, but that's not always true. That's not always true. Okay, the sign alternate even here. The sign alternate here. Right, you see plus, minus, plus, right? Okay, keep on alternating. But that's not always true though. Okay, that's not always true. I hope tomorrow I have a chance to explain to you under what situation it happens like that. It's always alternating, and under what situation it's not. Okay, so I do testing point x equals to 0. So when I plug in x equals to 0 here, that will be 2. Here, that will be -1. Here, that will be 4. Okay? Actually, I just need the plus times minus times plus. Okay, I just need the plus minus plus. So if you only look at my lecture notes, you will see that it seems like, how do you get these terms? Okay, but if you watch this video, then we'll see there's plus when I plug in here, right? When I plug in here, it will be plus, minus when I plug in here, plus when I plug in here. So that will plus, minus, plus. Oops. Oh, oh. Did somebody move my screen? No, please don't move my screen. So plus minus plus, that would be negative. When x equals to, let's say x equals to 2, then it will be 4, 1, 2. That's positive. When x equals to, let's say 5, I will get 7, 4, -1. Oh, there's negative here. When x equals to, let's say, -5, it would be negative. Negative. -5 becomes positive. 4 minus -5 is positive. So that will be positive here. Then we go back to our inequalities. Oh, I need something less than equals to 0. So step 3, solution. I need negative or 0. The one that gives me negative or 0 will be interval from -2 to 1, including -2, including 1, union 4, including 4, up to infinity. Okay. Now, I will apply the same idea now to rational inequality. I will apply the same idea now, exactly the same idea into rational inequality. Let's say, so let me just mark it as number 3, rational. Suppose, for example, I just go ahead, do number 40. Solve x plus 6 over x squared minus 7x plus 12 less than equals to 0. My step 1, critical numbers, is I set this equals to 0, but we anticipate the situation when it may be undefined or undefined. Okay. Now notice that the other side has to be 0 though. This side has to be 0 just like before. back to the denominator, that's x minus 4, x minus 3, equals to 0. So the critical numbers are x equals to negative 6. That will make it 0. X equals to 4 will make it undefined. X equals 3 will make it undefined. Okay. Now then, how about the sign graph? So for those, I get negative 6, 3, and then 4. Negative 6 will make it 0. 4 will make it undefined. When x equals to 3, the expression will also be undefined. Okay, now the ones that make it undefined also a critical number, because if there's any change of sign, it must happen to the zeros or the undefined. Okay, now we didn't worry about undefined case in polynomial because the domain of all polynomials is all real numbers. Any polynomials, whatever x you plug in will give you a real number. But when it comes to rational expression, there are some x's, there are some values of x that does not belong to the domain. Like here, when you plug in you plug in 3 here, the denominator becomes 0, and that will make the whole inequality, the whole expression becomes undefined. Okay, so the only new thing in this rational inequalities is we need to account for the critical numbers coming from the 0 of the denominator. We need to account for the critical numbers that makes the denominator become 0. Okay, not only the numerator, but also the denominator. Okay, now everything from here, we go as usual, just like before. Let's say we test x equals to 0. There will be positive 6 on the top over negative 4 at the bottom times negative 3 at the bottom. That will be positive divided by positive. The overall is positive. Between 3 and 4, oh shoot, then I need to pick some ugly number, let's say 3.5, right? But don't worry, we don't need to compute that precisely what's the number. We just need the sign, right? So 3.5 plus 6 on the top, that would be positive. 3.5 minus 4, that's negative. 3.5 minus 3 is positive. Overall, that's negative. Let's say for this one here, we choose x equals to 7. So on the top, 7 plus 6, that's positive 13. 7 minus 4, that's positive 3. 7 minus 3, that's positive 4. All of them positive, so overall that's positive. Likewise here, let's say x equals to negative 10. That will be negative over negative times negative. That's negative. Okay, so you need to get used to this though. If anybody, any tutor or other instructor, I don't care. Okay, if you are in my class, you do it my way. Okay, I'm kind of tired with some people try to use one way, and then they later on say, oh, you know what, this is how I do it, I get the right answer. But then if you apply the same method to other topics, other situations, they get it wrong, and they don't even know why they get it wrong. Okay, do it properly. This is the proper way to do it. Okay, even our textbook actually show this way, except the way they do sign graph is different from mine because they try to explain it in more details. Okay, now then, as for the solution, let's move on. We need negative or 0. Right? We need negative or 0 solution. Negative or 0 will be the negative part here, including this, and the negative part here, but we'll never include undefined. We never include undefined. In any case, we never include undefined. Basically, when you plug in 3 into this expression here, it will be tag. Okay, when you plug in 4 there, it will be tag undefined. So under no situation that 3 and 4 become solutions for everything. Okay, if you consider this 3 and 4, if you consider this as your party, 3 and 4 are not invited at all. Okay, 3 and 4 are not invited at all to this party. Okay, now, so the solution will be, I need the negative parts of those intervals that will give me negative infinity up to negative 6, including negative 6, because negative 6 give me the 0. Okay, union 3, 4. I don't include 3, I don't include 4 because 3 give me undefined, 4 give me undefined. Yeah, so far we still have situation where the sign will alternate. I still want you to, for today, I expect you to do your suggestive homework. I want you to do it this way first, okay? And tomorrow I will show you a little shortcut. If you do your problem, the suggested homework, then you will see the case where the sign does not change between, like let's say the sign here is positive and happens to be the sign after the critical numbers also the same positive. It is possible though, okay? So the best way to know for now is do the testing point, okay? I need you to get used to that procedure first, and then tomorrow I show you what makes that to happen, okay? Now, last question for the day. Number, for example, let me choose the harder one. How about number 46. Solve, this is rational inequality, 2 over 2x minus 3, I'm sorry, 2x plus 3 less than equals to 2 over x minus 5. What we need to do is, you set one side equals 0. So what I need to do is I will move, for example, in this case, I can move this 2 over x minus 5 to the left-hand side, okay? To make it less than equals to 0. 2 over 2x plus 3 minus 2 over x minus 5. Okay, that's how you do it. Now, I think I need to make you aware right now, note, when solving rational inequality, do not multiply by the LCD. You see, if we had equation 2x minus plus 3, 2 over 2x plus 3 equals to 2 over x minus 5, we can multiply by the LCD. We can multiply by the LCD such that we get 2 times x minus 5 equals to 2 times 2x plus 3, right? Now, the reason it was doable there and not here is because when you multiply by the LCD in the equal sign, it doesn't matter what is the sign of 2x plus 3 and x minus 5. You see that 2x plus 3 can be positive, can be negative. x minus 5 can also be positive, can be negative, depends on what your x, right? Okay, but in equality, it doesn't matter it's positive or negative. When you multiply by 2x plus 3, it will still be equal sign. However you reverse the inequality, however you reverse the equal sign, it will still equal, right? Okay, but when it comes to inequality, this step is not possible. When you say you multiply by the LCD, right? When you multiply by the LCD, then we have issue with the sign. Is it stay the same? Or will that be reversed? Okay, that's the issue. That's the issue. Will that be the same or will that be reversed? Because we don't know what's the sign of 2x plus 3. When x is greater than 5, that will be positive, right? Because when x is greater than 5, let's say 10, this will be positive, this will be positive. When x is greater than 5, you don't need to change the inequality sign. But when x equals to negative 10, for example, or let's say x equals to 0. When x equals to 0, this is positive, but this is negative. So there are times you need to reverse inequality sign. For some x, you need to reverse. For some other x, you don't need to reverse. So there's just too many possible cases. So don't do that. Okay, don't do that. What happened with this? What happened with this? Something not really right with my pen. I bet. I think my computer gets some nasty stuff. Okay, so that's not the step you can do. Okay, pay attention to this. I write it big and write a big do not there for a very big reason. Because I have seen people, students try to do their own ways simply because their tutors actually taught them that way. Trust me, trust me. They're tutors, okay? Not that I don't appreciate them, okay? But anytime they teach different from my way, then they must be wrong. Okay, I don't know why that it keeps on moving though. Okay, let me come here. Let me come here. Then what do we do at this point? We will need to put them into the same fraction. So basically we need to combine this, simplify this. And that's why we learned that 2 days ago. Okay, we do the LCD. The LCD is 2x plus 3. We still need to do LCD, but you should not multiply by the LCD. That's what I was saying. 2x plus 3x minus 5. This is 2 times x minus 5. This is 2 times 2x plus 3. Okay, now I will put them together. See what happened again. That's not what I did. Give me a second. Okay, so the denominator will be 2x plus 3x minus 5. The numerator, I will have 2x minus 10 minus 4x. What happened? I'm sorry. Something not right with my computer. Have you ever heard something called Zoom bombing? Zoom bombing is when somebody actually try to bother the instructors by doing this thing. That's minus 4x minus 6, which will give me negative 2x minus 16 over 2x plus 3x minus 5 less than equals to 0. So now we have one side is 0 and the other side is only one fractions. Okay, and it's already factored now. You can actually factor it further if you like. This is negative 2 times. What happened? Negative 2 times x plus 8 over 2x plus 3 x minus 5 less than equals to 0. Now then I will start the procedure. Step 1. I have 4 minutes left for this class. Of course, I can go a bit over, but let's see if we can finish it in 4 minutes. Critical numbers. Negative 2 times x plus 8, 2x plus 3, x minus 5. Set it equals to 0 or undefined when we'll get to undefined. On the numerator, the critical number is x equals to negative 8. On the denominator, the critical numbers are negative 3/2 and 5. Now, how about this negative 2 times? Negative 2 will always be negative for whatever x, right? So for that part, we can ignore it for the critical numbers. However, we need to account for that when we do the sign graph. We have negative 8, negative 3/2, and 5. It will be undefined when x equals to negative 3/2 and when x equals to 5. It will be 0 when x is negative 8. Now then, I plug in numbers, I test, let's say I test 0. When x equals to 0, then I will get negative 2 times 8 over positive 3 times negative 5. That's positive here. Okay, and then you test, let's say you test x equals to 10, for example, then it will be negative 2 times positive over 23 times 5. That's a negative here. So on and so forth. You will see this is negative, that's positive. Okay. And finally, when we get to the solution, we need that to be negative or 0. Right? So I need the negative or 0, including the negative, 0 including the negative including the 0. The negative including 0, but never include undefined. So the solution will be negative 8 up to negative 3/2 in parentheses union 5. Okay, now there are some little parts that we have not done for for this section, which I will continue tomorrow. But your suggested homework will be 1.6 number 7 to number 49. But for now you skip. For now you can skip number 17 to number 26. Let's skip those. I think that's for today. Yeah, tomorrow I will finish up this 1.6 just a bit more. So tomorrow I will do 1.6. We pretty much done with 2.1, but I want to browse through that again just to make sure that we are fine. And we will also do 2.2, just a little bit more. And then go to 2.3. So tomorrow we'll do quite a bunch. But I believe you can do all the problems in the the quiz, the homework, right? You know that I post a quiz. And I believe that's quiz 1, 2, 3. Okay. Yeah. Please start working on that. The due date for that quiz is Monday. Monday at 11:15, as I remember. Okay, then. That's today. See you tomorrow.
Professor?